Welcome back to my channel, students. Today I want to continue the polynomial, the first concept which I had already told you, which is the video I shared with you what is polynomial or the introduction to polynomial. Now we shall continue with the same concept, and we will learn something more about the class 10th chapter 2, that is polynomial. See, in the polynomial, the last concept I had concluded in the last class is what is the monomial, binomial and trinomial. In the same way, I already told you about the linear equation and quadratic equation and cubic equation. In monomial, binomial and trinomial, there is no such condition. Only the condition is that the term should be the single term for the monomial, 2 terms for the binomial and 3 terms for the trinomial. And the powers or the exponents should be the whole number. But as for the case of the linear equation and quadratic equation and cubic equation, there is something different. What is that? If I say for the linear equation or for the linear polynomial, if anything you can say, and for the quadratic and cubic, if I say for the linear, if I say ax plus b, for quadratic this is the ax square plus bx plus c, for cubic ax cube plus bx square plus cx plus d. Remember, here the degree is the one, that's why this is the degree is the one, that's why this is the linear. But remember, the main condition is that here the coefficient of x, that is a, the coefficient of x a should not be 0. Remember, the coefficient of x should not be 0. In the same way, the coefficient of x square, that is a here, should not be 0. In the same way here also, the coefficient of x cube, that a, should not be 0. Why? Because if the coefficient is 0, then what will happen? This term becomes 0. If this term becomes 0, then what will happen? The degree may change. Then we can say this, if I write ax plus b, where a equals to 0, then what will happen? This term becomes 0, means 0 plus b is the b. Then what is the degree here? The degree is 0. In the same way, here also if I say the a equal to 0, then what will happen? This term become be 0 and this will be x plus c, here degree will be 1. That's why we have to keep in mind that the degree should be, the degree is the highest power, and the same way the coefficient of the highest power, or the coefficient of this x square or the x cube or the x should not be 0. Then only this condition linear and quadratic and cubic equation will be happen. Means the only condition will be satisfied here, these coefficients should not be 0. Now we'll move to the next concept. Now we'll understand the zeros of the polynomial. What are the zeros of the polynomial? I already explained about how to put the values in a polynomial. Now I will take an expression px equal to 4x square plus 3x minus 1. See, in place of x, I will put the value as minus 1. Then what is the value? You see, p of minus 1, this is 4 into minus 1 square plus 3 into minus 1 into minus 1. This will be 4 into 1, minus 1 square is a plus 1. This is minus 3, minus 1. This will be 4 minus 3 minus 1. This will be 4 minus 4 equal to 0. Means, when x equal to minus 1, the px becomes 0. Then, when x equal to minus 1, then px becomes 0. Then, this minus 1 is called the zeros of the polynomial. In the same way, as we know, this is a quadratic equation. Here, surely there will be 2 zeros. Why these 2 zeros are there? And what is the importance of the 0? Everything we'll understand bit by bit when we'll go to the geometrical representation of the zeros. In the same way, if I'll take the another expression, px equal to 5x plus 3. Then whenever we'll put the x equal to minus 3 by 5, then what will happen? Px equal to, p of minus 3 by 5 equal to 5 into minus 3 by 5 plus 3. 5 will be cancelled out. This is minus 3 plus 3 will be 0. Means at x equal to minus 3 by 5, px becomes 0. Then minus 3 by 5 is the 0 of this polynomial. Now we'll understand what is the importance of the 0. Why zeros plays the crucial role in the polynomial. That we can understand very easily whenever we'll understand in geometrical representation. Now we'll move to the geometrical representation. Now see, we'll understand the geometrical representation of zeros. For this, as we know, this is a coordinate geometry. This is a concept from the coordinate geometry. I think most of the students were not gone through very clearly about the coordinate geometry, but you people are some knowledge about the in data handling concept. In data handling, what we know, drawing the bar graphs and everything. In the same way, in this basing on the concept, just I draw the two lines, which is this is the x-axis and this is the y-axis, and they both meet at the point origin. That origin point is said to be 0, and right side of this origin 1, 2, 3, 4, 5, 6, 7, and the left side of the origin there will be minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, as like the number line. As like the number line, you can just analyze this one or resemble this one. Whenever you go to the right side of this 0, this is the positive. Whenever you go to the left side of the 0, this is negative. In the same way, if you go to the upward, this will be positive, and downward is the negative. Means it is completely the positive and positive point. This is completely negative and positive point. This is a negative and negative point, and this is a negative and positive point. But how we'll put the values? The putting the values and everything you will understand in the coordinate geometry. Rather, I will just simply in some short words I will explain. See, if I will put what is the position of these 3? As 3 is the some distance apart from the origin. This is some distance apart from the origin, means some distance from the y-axis. Means from origin it is a 3. But what about the x-axis and y-axis? Here we will understand. Again I am saying this 3 position is the position of any point where we will understand what is the coordinate of this 3. For understanding this 3, I will write here, first of all, from x-axis, in x-axis what is the distance, in y-axis what is the distance, we have to understand. In x-axis it is the 3 units. But what about the y-axis? Here see, in y-axis there is we don't have any point coordinate with the y-axis. That's why we can say this is the 3, 0. In the same case, if I write this position in the y-axis, this is the 0. Sorry, in x-axis for x coordinate this is 0. For y coordinate this is 3. That's why this position is termed as a 0, 3. Whereas this is the 3, 0. Again I am saying, see, this is the 3 units from the origin in the x-axis. That's why the value of the x coordinate is 3. But as for the y-axis, there is no distance. That's why we can say is the 0. In the same way, for this point, I can say this from y-axis. In the y-axis, it is the distance is the 3 units. That's why in the y coordinate is the 3 and x coordinate 0. What is this x coordinate and y coordinate? Whenever in a coordinate geometry, whenever we represent the point, what we'll do, we have to understand in the two coordinates. One is the x coordinate, another is the y coordinate. The first is the x coordinate, here is a 3, and y coordinate is a 0. In the same way, here x coordinate is 0, the y coordinate is 3. Whenever I will say 2, 3, 2, 3 means in x coordinate we have to see the 2 points or 2 units. For y coordinates, this is 3 units. Just see. If I see the first we have to move through the x coordinate 0, 1, 2, this 2, and from that point we have to move for the y coordinate from here 1, 2, 3. This is the point where we can say as the 2, 3 coordinate, or the 2, 3 point is there. Basing on this concept, we'll find the sum of the values. Now I will take an example as 3x plus 2, as polynomial px equal to 3x plus 2. Now I just want to express this polynomial in the coordinate geometry format or in the plane, where the plane is x, o and x naught and y, o and y naught, but this y plane, y axis, I will represent as the px. Understand, my students? Here the polynomial px equal to 3x plus 2 I want to express or represent in the coordinate format or in the plane. Here what I will do, I will take the sum of the values for x and put the values in this polynomial, and I will draw a graph for this. Just see, this is a table in which I will take the x and px. If I take the x as minus 1, the value is the, here if I put the x as minus 1, this 3 into minus 1 minus 3 plus 2 is the minus 1. And if I take x as the 0, then the value is 2. If I take the x is 1, 3 into 1 will be 3 plus 2 is the 5. Now I will put the values in the graph here. See, here the minus 1 and minus 1, and here 0 and 2 and 1 and 5. 1 and 5. This is 1, 5. This is 0, 2 and minus 1 and 1. Here see, if you draw this graph or if you join this line, then what we will get? Let's see, if you join this line, what we will get? See, after joining this line, after joining these 3 points and this line, cuts the x-axis at point minus 2 by 3. And then the coordinate of this point will be minus 2 by 3, comma 0. Just now, to get the more knowledge about this, just I am putting this value in this equation. What I will get, let's see. If I take the polynomial 3x plus 2, 3 into minus 2 by 3 plus 2. If 3 will be cancelled out, this will be minus 2 plus 2. This is the 0. That means what? The line where it will cut the x-axis, that point, when we put this point, this is this point, when we put this point or this value in this polynomial, then we will get the 0. Means we can easily understand this point is the 0 of this polynomial. Means for this polynomial there is only one 0, and that 0 will get sorry, that 0 will get by the line which cuts the x-axis. Understand, my students? In the same way, we can find the zeros for the linear equation. If I take the equation px equal to x, see here, if I take x and px, if I take 0, this will be 0, this will 1, this will also 1, this will 2, this is also 2. Here take 0 and 0, 1 and 1, 2 and 2, 2 and 2, and 3 and 3. In such way, if we join the line, this will be straight line passing through the 0, and this will be the line cuts the x-axis at point 0. Then we can say for this equation, for this polynomial, then we have only 1 0. Means for this polynomial there will be at most only 1 0. At most only 1 0. Understand, my students? Now we shall understand for the quadratic equation. Now we shall understand for a polynomial for quadratic, any quadratic form. Just take px equal to x square. See, that I will draw a graph for the px equal x square, that you might see what is the difference or the what shape we are getting. Let it the x is minus 1, then x square will be plus 1. If x is 0, this will also 0. If x is 1, this will be 1. If x is 2, this will be 4. See, for minus 1, this will be plus 1. For 0, this will be 0. For 1, 1, 2, this will be 4. See, the graph will looks like in such a way. See, this shape is called the parabola. And remember, this px equal to x square, this shape only we can get for the quadratic form. In the same way, we'll take the another example, px equal to x square minus 4x minus 5. See, in this equation, now what we'll do, we'll draw the one graph for this. See, for x, I will take the x and px here. X and px. If I take the minus 2, what will get the value? Then we can understand easily. If you will take the minus 2, we'll get the 7. If you will take the minus 1, we'll get the 0. See, if minus 2, this will be minus 2 square 4. Minus 4 into minus 2, minus 5, we'll get the 0. If we'll get the minus 1, then we'll get the value as the 0. And let's take the value as the 0, then we will get the value as minus 5. In the same way, you can take the value of the 3, you will get the value as the minus 8. In the same way, take the value of 4, you will get the minus 5. In the same way, you will take the value of the 5 as the 0. See, put the values and now draw the graph. Minus 2 and this will be minus 2 and this will be 7. Let's take this is the 7. This is the 7. Minus 2, this will be 7. Yeah, this value is the minus 2, 7. Next, minus 1, 0. This will be minus 1, 0. Next, 0, minus 5. 0, minus 5. This will be 0, minus 5. Next, 3, minus 8. This will be 3, minus 8. Next, 4 minus 5, 4, this will be minus 5. Next is the 5, 0. This will be 5, 0. Now just draw the graph. That what we'll get. See, this is also the shape of the parabola. Means we can understand when for the quadratic equation, when this value is the x square or the x square minus 4x minus 5, remember the most important thing, what is the coefficient of x square? Generally, that we took the coefficient of x square as the positive. Means here a is the positive. That is, a is greater than 0. If we take the a less than 0, remember the shape might be in such a way. Or the parabola is in such way. Means just flip to this shape. In the same way, if you take the any example, if a greater than 0, then the shape will be upward, and if a less than 0, the shape will be downward, or this will be flip. The shapes will be flipped with each other. Now we'll take the some more example, and we will see whether how many number of zeros we'll get. Here see the number of zeros will be 2. Means one is the minus 1 0 and another one is 0 5. Means 5 0. Minus 1 0 and 5 0. Means you are getting the here two zeros. One is the x equal to minus 1 and another is the x equal to plus 5. Now see, I will represent them for the quadratic equation. In quadratic equation, I will take the three cases. For each case, two cases. In every case, a is greater than 0, and for one graph a greater than 0, for another graph a less than 0. For everything, the expression or the polynomial is the ax square plus bx plus c. In ax square plus bx plus c, first I will take the a greater than 0. For a greater than 0, this graph, see in such way. Here, in this case, this cuts the x-axis. This cuts the x-axis at 2 points. Hence, the zeros of this polynomial is the 2. In the same way, for a less than 0, see a less than 0, it cuts the x-axis again in 2 points. Hence, this is a 1 point, this is a 1 point, and here also the zeros are 2. But for case 2, I will take the, see, in case 2, it meets the x-axis at only 1 point. It meets the x-axis at only 1 point for a greater than 0, a less than 0. Then we can easily understood the zeros of this polynomial. For this polynomial, this is the only one. But as the case of C, this is like this or like this. Here it does not, or it never meets the x-axis. It never meets the x-axis. Here it is a less than 0, it is a, sorry, it is a less than 0, it is a greater than 0. See, here it never meets the x-axis at any point. Means here the number of zeros is the 0. Means in this case, from this we can understood, in a quadratic polynomial, the maximum number of zeros is the 2. If it cuts the 2 points, then this will be 2. If it meets at 1 point, this will be 1. And it never meets, this is a 0. Means the possibility of number of zeros for a quadratic equation is the maximum 2. Not 2, this maximum 2. It might be 1, it might be 0 also. Now we shall move for the cubic polynomial. How the number of zeros we can find, and what is the shape for the cubic polynomial. Now see, for the cubic polynomial px equal to x cube, this graph meets the x-axis only at 1 point, that is the 0 and 0, and hence the 0 of this polynomial is the 0. But for this case, see, it meets the x-axis at 2 points. In 1 point it meets the x-axis at 0, 0. At another point it cuts the x-axis. These 2 points are the, hence the zeros of this polynomial is the 2. Means it cuts the x-axis at 2 points. Or 1 point it meets the x-axis and another point it cuts the x-axis. But for this case, see, this polynomial is the x cube minus 4x. Here the graph meets the or cuts the x-axis at 3 different points. This is 1 point, this is another point, and this is another point. Means here the zeros are the 3. Now we can easily say the maximum zeros for a cubic polynomial is the 3. It may be 2, it may be 1, or it may be 0. Means we can say easily, for a cubic polynomial, at most we have 3 zeros. It may be 2, it may be 1 also. Now we can easily understand, for any polynomial, the maximum number of zeros is equal to the degree of the polynomial, and the minimum number of zeros is the 0. And hence, at most, how many number of zeros we can get for a polynomial? That is the the degree of the polynomial is equal to the zeros of the polynomial. The maximum, at most we can get. Understand? Now we'll go to there is a relation between the zeros and coefficient of the polynomial. Let's get started for the zeros and coefficient of the polynomial, or the relation between zeros and coefficient of the polynomial. But we'll get understand all this in our next video. Let's wait for our next video for the relation of zeros and coefficients. And also in this video we can understand two more concepts. One is that how can we find the equation by knowing the zeros of the any polynomial, and also another concept you can understand, that is the last concept for your this chapter, and you can easily understand all the concept in my video. Now thanking you all. That is zeros of the polynomial. What are the zeros of the polynomial? Before going to understand about the zeros of the polynomial, let us consider what about the expression and what is the equation. First, we will understand about the expression and equation. See, if I say ax square plus bx plus c is an expression, if I say is equal to 0 is an equation. That about the expression and equation, you attended so many classes. If you don't know, just you put a message in my comment box. I will explain you. Now we'll understand. If I will consider this is the expression, I will consider this is the expression, and the other name here the polynomial. I will write here this is a polynomial p. This is a polynomial p. Here, what are the variables used here? This is the variable is the x. Now I can write easily p of x is ax square plus bx plus c. How? Here the p is the polynomial, which is the ax square plus bx plus c. X is the polynomial which is based on the variable x. That's why p of px is equal to ax square plus bx plus c. If I change here, this is y. That means what? This is completely depend upon the y only. Means this is ay square, this is by plus c. Understand, my students? Means py means ay square plus by plus c. This is the polynomial where it determines whether what is the variable used here. If I write here rather than py, if I write here pz, this will be az square plus bzc. If I write the pt, then this will be at square plus bt plus c. Understand? Means here this is a polynomial, and this the term which is within the bracket signifies which variable is used. If you will change the variable, then in entire polynomial the variable will change. If I write p k, then this will be ak square plus bk plus c. Sorry, bk plus c. Then if I write another polynomial px equal to ax plus b, and I will put the k in place of the x, this will be ak plus b. That means what? This is the value of this polynomial. This is the value of this polynomial when we'll put the k in place of the x. Means if I'll put, just for an example, I will take one number. If I'll take the number p1, then what will happen? Let's take, I will take an example as the px equal to 4x square plus 3x plus minus 2. Sorry, px equal to 4x square plus 3x minus 2. If I'll put the 1 in place of the x, then what will happen? 4 into 1 square plus 3 into 1 minus 2. Then this will be 4 into 1 1 plus 3 minus 2. This will be 4 plus 3 minus 2. This will be 5. Then what will happen? This 5 is the value of px at x equal to 1. This 5 is the value of px at x equal to 1. Understand? In the same way, this pk means ak plus b is the value of px at x equal to k. Means this is the value of px at x equal to k. In the same way, this is the value of px. This is the value of px or pt or pz when z equal to k or t equal to k. Understand, my student? This is the, we are determining the value. First we understood about the expression. What is the, first you have to understand the expression, then about the equation, then what about the polynomial, and how we will write this polynomial with the variable, and how we will change the value putting the values. So see, if just for, I am repeating the same concept here, I am putting here 1 here, then what will happen, the entire x will change into 1. Means here the x is there, rather than x I kept as the 1. Here x, here also x is there, here also I kept the 1. Means 4 into 1 square root 4 plus 3 into 1 3 minus 2. As here there is no x is there, that's why the value will be 5. Means from this one you can conclude that this position, if you change this position, the entire positions of these values may change or will change. Understand, my students? Now we'll move to the our next concept. What is the zeros?